setting up a scene. From now on, I won't always show the documentation window. We will be focusing on Unity itself. So if you want to follow along, just open the documentation as it's written here, as I will do on my second screen here, and I will just follow the documentation and maybe do some comments all along the way. All right, the goal of this 102 lesson here is to create a working multiplayer application with just basic shapes as player avatars, but all the fusion magic already in place. So I will just follow the documentation now, and we'll see where we are ending up. So first thing we want to do is to create an empty game object. Empty, fusion empty, okay. And call this the basic spawner. And then we will be adding a script called the basic spawner script. Spawners basics spawner script damn chuck thump. We will open this. Here we go, our basic spawner script. The first thing we want to do here is implement the interface INetworkRunnerCallbacks, which I will do. NetworkRunnerCallbacks with a big capital N. And we need to be importing this, and we need to import this, to implement this interface, and not throw any exception, which is now So I think I will cut this out in the video. What this interface does is, according to documentation, it will allow the network runner, which is the major networking component of Fusion, to interact with this basic spawner. And if you look at these methods, one can already see when they are actually called. These are lifecycle methods and other things. And yes, once this is implemented, we can actually go on and with the next step, which is to add a StartGame method, which, if I remember correctly, is automatically called. So I will type it, I think, instead of copy and pasting it, so to be able to just talk a bit about it. So we have this async StartGame, async void StartGame method. And the first thing we want to do is we want to add a runner, which is never defined here, equals game object dot add component. We need to add first thing we want to do is to have the network runner added here, and okay, it comes a bit below. So documentation tells us to add the code before we add the variable. So obviously this is a network runner component, and so now this works. So we're creating the network runner, the main network runner, and we want to add a provide input equals true, which means that we will be able to provide input from this instance of the basic spawner, so from our server instance. And then using this runner, we are starting the Fusion application, which will be done like so: runner.startGame, start not coroutine, but start game. And we want to have a new StartGame X, which I guess can have a lot of parameters like so. And let's check it out. What do we want to set? We want to set the game mode to mode. Where is this? Ah, this is what we are using above. We want to have a session name, which is a fixed session. I think this is something like a room name, because in the documentation they're calling it test room. And we need to have a scene manager here. No, we want to have the scene equals scene manager. Scene manager. It's not here yet, so we need to import it. Scene manager dot get active scene scene management dot build index. This is the scene and the scene manager itself. Manager equals game object dot add component network scene manager default network scene manager default, which according to documentation is not necessary for this sample, but this is the startup code. And obviously what this does is it starts the network runner on the same game object as we implemented our INetworkRunnerCallbacks, which allows the network runner to identify our basic spawner component here and interact with it. However this is done. So the next thing we want to do is we want to have on GUI method, which is a void and GUI like so, and we're just adding some basic interaction for starting the game in a host mode or in a client mode. So if runner equals 0, then we want to create a button with new rectangle 0, 200, 200, 200.40, 40, and with a button of host the game. And if this is successful, then I know if this is pressed like so, start game with the game mode of host. And this is where our start game method is called from the UI. And I think this very same is true in the client mode. So we want to have in a join, and this is client. So like so, our GUI method, which will be created. And actually, this can be run now, but we do not have anything in here. We can just start the game, but I will just test this in a second. Okay, good that I tested because I have no unit tests, obviously. So I found two little bugs or mistakes here. First of all, the second button obviously needs to be at 04T because else it will just be written over the host button. And the second problem was that I am starting in full screen mode, which is not the best idea if you want to have multiple instances. So for this, we go to the project settings and just change the player resolution to windowed like so, and then we can actually build. So now we can build our project here in our, I already have this, but I build it here. And after this build successfully, there is this executable now. We can open it up and it will start our nice Unity project with these two buttons. A second one. And here we go. And now the one can be the host, the other can join, and nothing is visible, but this is to be expected at this point. Let's continue by creating a player avatar. Creating our cube avatar also looks quite straightforward. So it's simply adding a new game object, calling this one player prefab. And then we add a component called the network object component, network object, like so. This will allow Fusion to identify and the network object give it identity over the network. And then the documentation says that since this will be a user-controlled avatar, it's a good idea to add a component which is called network character controller prototype. Network character controller prototype, here it is already. And this will also add the character controller, like here. This is the normal one from Unity. And I didn't investigate, there's a warning here what this all means, but it looks the same way in the screenshot, so all is good. And now we want to have, and we also reset the transform because it's somewhere. Where is my, here, okay. Let's go a bit here, because in a second we will add a cube here, and we will add a 3D object, a cube, and as a child object to the player free prefab, we rename this to body, and then we will remove the collider from this cube because this will obviously not be necessary, and we drag the body game object to the interpolation target property of the network character controller. Blah, blah. So the network game object, network character controller, interpolation target, this is this one, so we will use this and drag it here, and here we go. And the avatar should now look like this, so let's compare this with the documentation. This is correct, and we have auto, we have world, we have the body transform, we have gravity is -20, this is big gravity, so I'm not sure why we go to a realistic one of 0, 1. The jump pulse is 5, 10, 10, 4, 15, just for the sake of everything the right way. And now this looks good, and probably this should be testable in a second as soon as we have this player spawned, which is done again from Visual Studio Code. In order to have our player spawned on all the attached clients, this code must be executed on the dedicated server, on the dedicated host. And this will be done in these two methods here. We have the onPlayerJoin and onPlayerLeft method, which are automatically called. And obviously in here, we need to call some kind of spawning method, which will then allow Fusion to spawn this player character and this player avatar in all instances of this session, of this room. So in order to do this, we need to have our player prefab, which we want to spawn. And I will add this to the top, probably to the top, too many callbacks here. So we need to have our serialize field. See, where's my serialize field? This is a private network prefab ref, network prefab reference, which is called the player prefab. This will be set then from the Unity editor. So jack, bam, and then we implement the onPlayerJoined one, which does the following. So if runner is server, only on the server do we spawn things. And then we have vector3, the spawn position equals new vector3, and whoa, that's some weird syntax, so let's check this out. So this is the player dot role encoded, and then we have like so, never saw this one, runner.config dot simulation dot default players. So I'm very interested in what this syntax does. I have to investigate this. So what's this one here? Weird. 310. So I think this will just set them a bit apart from each other. Then we have to spawn this one. So we have a new network object. Network object. Network player object equals runner spawn. And takes our player prefab. So it's basically very similar to instantiating a normal prefab in Unity. So we have the spawn position, which we just calculated, and then I have to scroll a bit. So no rotation, identity, and the player reference as the owner. And this should actually spawn the player, and then we also need to have a dictionary of spawned characters. So we add this here. So it's a private dictionary of player ref and a network object. Network. Oh, caps lock. Sorry. Go away. Ref net object. Here we go. And this is our spawn. Oh, not my typing day here. Characters equals new dictionary blah. Correct. Yep. And then we can add our new network player object here to our spawned characters. Add the player and then network player object. Here we go. And this adds it to our dictionary in order to keep track of the player avatar so that we can later remove them, which we will do here. So if we are despawning, so we are trying to get from the spawned characters, we are going to try get the value of the player network player object for this player reference. So if the player leaves, we are trying to get this one. For the player, we need to have our out network network object, and this is a network object. If we get this, then we despawn it. Runner.despawn equals network object. Easy peasy. And we remove it from the collection. Spawn character, remove the player. So, and that's basically it. And this should be already working. So this should hopefully spawn static characters without the ability to move. We will test this in a second. And if this is running, then the next thing is to collect input and make these characters movable. See you in a second. All right, now let's test the second version of our little game. So a couple of things to do before we can actually run the game. First of all, we want to make a prefab from this player prefab, so it shouldn't be in the scene already because these are spawned when players are joining. So I move this simply to my assets folder here and have my player prefab here, and then I can remove the actual instance of this prefab, and then we need to set this to the player prefab in our spawner script, which we just created. So move this here, and this should be all which is needed to run the game. So now I've built this thing one more time, down, and then we will run it. Here it goes. And we will run the Fusion sample 1. And the second one. So one host, nothing happens. Now here is our first cube. Not exactly sure why this is taking so long. Then we're joining with the second client. And same thing, here it comes. So it takes about 2 to 3 seconds to spawn. Not exactly sure why this is the case. So just do a third one. I join this one. And same thing here. It takes a while to actually get the connection. And now if I despawn, now this happens fast. So I think once it's joined, then this is fast. So if I disconnect this one, it disconnects automatically. All right, test successful. We can go ahead and make this one movable. All right, our cubes spawn nicely across the network. Now, the last thing to do in this 102 section of the tutorial is to get these things to move. So we were creating input collection and applying these inputs as movements to the avatars. So first of all, we need to create a structure which then will be used to collect the input. So we need a new script, which we will add here, which will be called the network input data.cs script, and we will be creating a structure, a public structure, which is called network input data, which will derive from INetworkInput, which will then allow Fusion to input data, which will then INetworkInput. Why is it not? Should be in there using Fusion. INetworkInput, not visible. Why it's not visible? What's that? Didn't write this, right? Okay, and this structure will only contain a vector 3, which is the movement direction. Vector 3 direction. The tutorial tells us that since this structure will be transferred over the network with a rather high frequency, it makes sense to optimize this and, for example, not use the vector 3 if you only want to have directions like input directions, but also not to think too much about optimization, because the actual framework will optimize a lot of the networking stuff, so only transfer deltas of this structure if something changes. Now back to our basic spawner, we will override the next method, and this will be the onInput. So this is called whenever the Fusion system collects input information from the clients. So what we will do is we will create our newly constructed network input data, where is it? Public struct network input data, it's not visible. Network input data, sorry, input data, whatever it's not here. Whatever, let's continue. So we are just going with this default keyboard input, so a very simple way of controlling the character. So we're doing a keycode WASD. So if we're heading upwards, we will set the direction, data direction, add a vector 3 forward, like this, and with an S, with an A, and with a D. So the S obviously is backward, back. This one is to the left, A is to the left, yes, and S is to the right. And then input.set data. So this is basically the input collection thing with could not be found, or you're missing. So I'm not exactly sure why it's not here, because it obviously knows this. We will see this once we compile. So maybe just do a compilation. No, vector 3. Okay. So why didn't it Unity, which comes from here, Unity engine, and then this should also be recognized here, right? Now it's working. Okay, and this is the input collection, but as of now, nothing is actually applied. So the second part now, since we have collected the input and the input is sent to the server, is to add this input, so to make this input movable on our player. So we go back to Unity, and now it recompiles, and now it works. Go to the player prefab, and we will be adding a new script here, which we will call, how did they call this? The player script. Very fantastic name. So we have a player script. Oh, sorry, it's a player spawn point, blah. Remove. I want to have a player script, damn you. Player, a new script, player, create an add. Here we go. And this player script will not derive from, open it please, not from mono behavior, but from network behavior. Network behavior, which obviously comes from Fusion, like so. And in this script, we will not use the update and start methods, but instead we will actually override the fixed update network method, which is the main method, the equivalent thing to update in a networked scenario with Fusion. So we will override the fixed update network and don't need to do this. And what we will be doing is we will be trying to get our input. So if get input, which comes from the network behavior in the variable network input data. So we try to receive this. If this is successfully received, then we go to the data.direction.normalize. So we normalize this thing, but as it's currently done, it's already not normalized. It should be normalized since we are only using these directions. And then we do the CC. The CC, CC is not defined yet, so this comes a bit above. So we need to have a network character controller prototype, which is part of our player. So we have this private network character controller prototype component, which we added in one of the previous steps. And we also need to get this one. So we have in the awake method, sorry, void awake, we will just get this with the get component from network character controller prototype, like so. Now we have this component which is attached to our player, and now we can move the player using this component with 5 times the data.direction multiplied by runner.delta time, which is the network equivalent of the time.delta time. So, and with this in place, our little application should now be running. We should have, hopefully, movable characters within the scene and fully networked. So I will try this out in a second. One last thing before we can test this is that actually right now, since the character navigation controller prototype thing is attached, which use physics and which means our nice cubes just vanish because we have no floor. So we just add, as suggested, a new game object, just a little cube, and we place it a bit below the other cubes and make it a bit bigger. So we will just, where is my transform here? We place it a bit below in the Y, so like so, and we scale it in all other directions, like 10, 10, and this should be it. And in order to be better visible, we might also create a little new material, call it floor, and we will just make this floor in a kind of reddish way, so like so, and attach the floor to our cube and call the cube floor. And now, since this is done, now we should be able to build the thing. Yep, please build it and run it. And then hopefully the cubes are not vanishing anymore. So I start one instance, I start two instances, close this one, host this one, and what do we see? Here's our cube, and now it's not vanishing anymore. Okay, for whatever reason it floats. When I started it last time, it just vanished through the floor, but maybe, yay, okay. We join here, and the second one, okay, works. Probably the collider is bigger than the cube or something like this, but as you can see, networking works fine, and this is the conclusion of the chapter 102 of the Photon Fusion tutorial. Before moving on, it's time to add this one to our Git repository. So we add all, and this is all we changed. So we have our basic spawner, our floor, network input data. So not many changes compared to the previous one. And we get git commit message feature 102 lesson 102, like so.